Okay, so this is the second video of the last series of videos that I'm going to do, which have to do with Chapter 6. Excuse me for a second. Chapter 6 is basically about polynomials. Okay, polynomials. And so this is where I'm going to just slightly go back over a couple of more law of exponents, and then also do some examples of that, and then I'm going to begin to do operations with polynomials. If this runs a little too long, then I may do a third video, but I'm going to try to squeeze everything in 25 minutes, so wish me luck. Alright, so we've already done introduction to law of exponents, right? Law of exponents. So remember, these are the ones where we say, hey, if we have a base and a power times the same base with a different power, we add those powers together. If we have a base and a power, raised to another power, well, we multiply those two powers together. If we have a base and a power, and there's some division going on with, different powers, well, we subtract, right? Okay, so those are the basis of it. Then we say that if we have a base raised to 0, it's always going to be equal to 1. And if we have a base raised to a negative power, it is always going to be 1 over, and then we put that base and that power positive in the denominator. And again, you're going to see some cases where I move my negative exponent around where he's more happy. Now here are two more law of exponents that are the new ones. So I'm going to change colors. So what happens if we have, two bases and the power is over here? Well, you separate. You say, hey, a raised to the m, b raised to the m. And then another one is, what if you have a fraction, like a divided by b? Again, those are different letters, different bases, and they're raised to this one single power. Well, then you separate them. You say a raised to the m over b raised to the m. There's no subtraction. Again, we're just raising it separately, all right? And I think those are the two new ones, and that's it. So now let's get into a bunch of examples, okay? So one example is going to be the following. What if we have -2, we got x, y, and z raised to the 4th power? Well, very carefully again, everybody who's in this parentheses, as you can see from this example, everybody gets raised to that 4th power. So you're going to have -2 raised to the 4th, and you also have x to the 4th, y to the 4th, and z to the 4th. Alright, so you can leave that x to the 4th, y to the 4th, and z to the 4th just like they are. But let's talk about this. This is -2 times -2 times -2 times -2. So I know -2 times -2 is a 4. 4 times -2 is -8. And then -8 times that 4th -2 is a positive 16. Alright, so the answer to this is 16 x to the 4th, y to the 4th, and z to the 4th. Alright, that's what we do there. Okay, now here's another example. What happens when we have, 5 x squared y to the 7th raised to the 3rd? So again, we're going to do 5 raised to the 3rd, x squared, but look, times 3. Y raised to the 7th, and then times 3. Everybody see that? So then this becomes, because remember, the law of exponents says we have to multiply when we have a power raised to a power. So 5 times 5 times 5 is 125. 2 times 3 is 6, so x to the 6. And then 7 times 3 is 21, y to the 21. And that's the answer for this one. Alright, pretty straightforward. All right, let's get into some fractions. Change colors. What happens when I have, 2 over 5 raised to the 3rd? Well, again, that's 2 to the 3rd over 5 to the 3rd. So 2 to the 3rd is 8. 5 to the 3rd is 125. And because 125 is only divisible by 5, right, there's nothing we can do to reduce him. And 5 can't go into 8, so that's our final answer for that one. And the next one, what if we have 3 to the 4th raised to the 4th? Okay. So basically we have, let me just expand this out, 3 times 3 times 3 times 3, and 4 times 4 times 4 times 4. And I'm going to have to really think about this answer. Okay, so 3 times 3 is 9. 9 times 3 is 27. 27 times 1 more 3, 6. That's 81. So 81 up here. And then I know 4 times 4 is 16. And then I know 16 times 4 is 64. And then I have 64 times that last 4. And that is what? Oh, 24. 256. There you go. All right. So now the last question becomes, well, can we simplify that, right? Well, I know 9 goes into 81. Can 9 go into 256? I'm just going to try. 9 dividing into 256. So 9 goes in there 2 times, because 3 times is 27. So 2 times for 18. I think this leaves me with a 7 remainder. 76. Nope. So no go on that. Another thing I can do is let's try 3, because I know 3 can go into 81 too. So let me delete a little bit of my scratch work here. Let me just try 3 into 256, because I know 8 plus 1 is 9, and if we get a multiple of 3, it's divisible by 3. Remember that from our divisibility rule. So can 3 go into 256? Well, 3 goes into 25 8 times for 24. 1 and 16. No, it doesn't. So I'm going to just leave that one like it is. If you can reduce or simplify that one, you know, again, just leave a comment in the YouTube box that you came up with a different answer on that one. Okay, because I'm kind of blowing and going through these. All right, the next one, let's try if there's a little bit more work. Okay, so what happens if we have 4 x to the 4th y, and then I have 2 x to the 3rd y to the 4th raised to the 4th. All right, so the first thing I notice is, okay, let's leave that first parentheses completely alone. And I'm going to tell you why we're going to do that. Because as you can see, because there is this 4, I want to just make sure that I'm going to break this guy down, right? So we got 2 to the 4th, and then we're going to do 3 times 4, which is 12, so x to the 12, and then 4 times 4, y to the 16th. So now I'm going to come back with this piece of information, and let me go ahead and raise my 2 to the 4th power. So 2 raised to the 4th power is 16, and then I'm going to put that x to the 12, y to the 16. And now I'm going to multiply. So 16 times 4 is 64. 4 plus 12 is 16, so x to the 16. And then there's a 1 here, so this is y to the 17th, and that's the answer for that one. Take your time. All right, I'm going to get into a couple more. All right, so now, what happens if I have something like this? Well, I have z raised to the 2nd power being divided by, and then I have w to the negative 4, w to the positive 4, and z to the negative 8. So remember, this is the one that I talked about, that wherever these people are not happy, move them. So I'm going to move this guy up, and this guy up. All right, so what that's going to look like is leave the z squared alone. Then I have w to the positive 4, z to the positive 8, and on the denominator there's a w4 at the bottom. Okay, and so now what can we cancel out? Well, we can cancel out the w to the 4 and w to the 4, okay, because they're the same value, so that's a 1. And then I'm just going to end up adding the 2 and the 8, which is 10. So the answer to this is z to the 10th power. Okay, hopefully that was okay. All right, let's do another one of those. What if I have x to the negative 6 over y to the 4th and z to the negative 8? All right, well, as you can see again, we're going to bring this guy down, and this guy is going to go up. So our answer is going to be z to the 8th is at the top, y to the 4th is there, x to the 6th is there, and you're done. There's nothing else you can do to that. Okay, let me do another one with some negative powers in it, and one other example, and then we'll be done with everything with exponents. All right, what about this one? I got negative 5, x to the negative 2, and then I have y to the 3rd, and this is all raised to negative 2. All right, this is going to be fun. So the first thing, just not to overcomplicate things, is I'm going to use a parentheses on that negative 5, and I know that he's raised to the negative 2. And then I have, you know, I'm going to just multiply that -2 here, and this -2 will change it to a +4. And then y to the third, and then 3 times -2 is -6, so I got y to the -6. Again, don't try to do too many steps all at one time. Just break things down really, really carefully and see what we got going on. All right, so now, in my mind, this is what's happening. So the first thing I noticed with this 5 to the -2 is that, okay, I got -5 raised to the -2. Well, here's the tricky part with this, guys, okay? That 5 is going to stay negative. The problem is where he currently is positioned, like -5 over 1, he's unhappy in the numerator. So the way I'm going to transform this is 1 over, watch this, -5, and then put a +2. Do not change the sign of that 5 because you changed his position. All right, he just comes down, he's happy now down below. Then you can evaluate that, and this would be -5 times -5, which is a, see, 1 over 25. So that's what that translates to. The x to the 4th was happy where he was, so again, I'm going to leave him in the numerator, and the y to the -6 was not happy, you know, being in the numerator, so we bring him down. And there's our answer. So the final answer is just x to the 4th over 25y to the 6th. Again, take your time and be careful. If you want to see one more of those that are kind of with that negative power on the outside, let me do one of those, and then I'll stop with all of that stuff. Okay, here's the last one. What if you have 2p to the -4, q to the 3rd, divided, then you have 5p squared, then you have a q, but this is all raised to the -3. Okay, make some room here. All right, so the first thing I'm going to do, and this is, you could do this in any order you want. I'm going to show this. This is the way my brain is thinking of it, okay? So the first thing I'm going to do is, you could, in the parentheses, because of the order of operations, you could just move people who are unhappy, okay, and then multiply with the -3 power. But I'm going to just make it simple and just do multiplying everybody raising to the -3. So I'm going to do 2. He's getting that -3 power. Then I'm doing -4 times -3. That's a +12. So p to the 12 is there. And then I'm doing 3 times the -3, which is -9. So I got q to the -9 over. Then I'm doing 5. And I'll put him in parentheses because of that negative power. Okay. Then I'm doing 2 times this -3, which is -6. And again, down here, he's -6. And then q raised to the -3. So we got a lot of negativity going on here. All right. So now next step, changing colors, is I'm going to go ahead and I'm going to say, hey, you're unhappy where you are. So he's going to come down. And guess what? This guy is going to come up. This guy is going to come up. These two guys are going to switch position as well. So now let's see what we got. So now, add in the numerator, we have the 5 to the 3rd power. Notice that that 5 is positive. I didn't change the sign or anything. And then the 2 to the 3 comes down. P to the 12 was happy where he was. P to the 6 comes up. Okay. Q to the 3rd comes up. And then where did that q to the -9? Well, q to the 9 came down. See that? Make sure you pause this if you need to see that again. So 5 to the 3rd is 125. 2 to the 3rd is an 8. Okay, and then I'm going to combine these two guys by doing addition, so that's p to the 18th. And then these two guys, you notice, will subtract, right? So 3 q's would go away on the top, 3 q's would go away on the bottom, and that would leave me with 6 q's on the bottom. You just subtract, okay? And I don't know, in my mind, you know, I don't think I can simplify 125 over 8. So that's the end of that. All right, so that concludes everything with exponents. I'm going to do a couple more actually, just to be safe, and then I'll stop the video because I don't want to, you know, this is going to be about 16 minutes. All right, then we get into this law here. What happens, these are some exceptions. What if you had this? What would that answer be? Think about that. Okay. Now, the answer to it is this. You put the negative, 5 to the 0. Remember, I'm not saying that I don't have this, guys. I don't have this. I just have the 5 is raised to the 0, so I leave that negative alone. -1. If I had the thing that I just wrote below, well, guess what that would be? +1. So be careful with that. Another one, what if I have c to the -3? That's 1 over c to the 3rd. Bring it down to the denominator. If I had 1 over y to the -5, guess what? Move him up. Just y to the 5th. All right. And if you have something like this, these are fun, right? What if you have -3/5 and it's raised to the -2? Well, you don't mess with the negative sign. You just, again, here's how you break it down. You say, okay, -3, just leave the negative alone. And then I'm going to say, hey, I have 3 to the -2, and I have 5 to the -2. That's one way to look at it. So I'm going to leave that negative alone again. And then again, these two guys are unhappy, so switch their position. So it becomes 5 squared over 3 squared, and this becomes -25 over 9. Okay, watch that one very carefully. All right? And I think that's everything I want to show for that, because now I'm going to just start another video. All right, so hopefully this was helpful. Again, you guys, this was kind of reviewing over a lot of exponents, review. So just, you can please now, replay what you need to, write some notes, make sure you're comfortable with it. And then what I want you to do is go to Connect Math, and I believe section 6.2, because I think I deleted out 6.1. That's the homework for this one. All right, you guys take care.